Students, how are you? Students, as you know that we have been discussing about limits in higher dimension, and in today's lecture we will look at a particular example that involve the limit in 3D. For example, if we look at a particular example, show that limit xyz, and due to xyz we call it 3D 0 0 0, and our function is xy plus yz plus xz, and it is divided by x square plus y square plus z square. We have to show that this limit does not sorry yes doesn't exist. Now let's come towards the solution. Now students, while discussing the limits in 3D, there is a procedure. The procedure says that, let me write it first. For three variable, basically var represents variable path, we use parameter t. Okay, and always choose axis as first path. Always choose axis as first path. What it says, let me explain. Now students, when we come across the of finding the limits in 3D and our function in 3D, then we have to substitute and use the parameter t, means we have to convert our limit in parameterization form and parameterization variable t. But first of all we have to try along axis, means it says that always choose axis as first path, means we have to first of all we have to check along x-axis like we did previously, and then after that we have to check along y-axis and z-axis, and then we will come towards the parameterization. Now students, if we talk along x-axis, now students, you know that in 3D when we talk about moving along x-axis, then our y and z becomes equal to 0. Okay, and now if I write here limit x approaches to 0, then definitely here our x times 0 plus 0 into 0 and plus 0 into 0, because our y and z's are 0. Sorry, here I also left with x. Okay, and in the denominator I will left with x square plus 0 square plus 0 square, and it would become equal to limit x approaches to 0 0 over x square, and it would become equal to 0. As you know that here our denominator is not 0, so that's why you can write it equal to 0. If your denominator gets 0, then you should try some other way to do it. Maybe there would be some common factors in it, you can cancel them and then solve them. Okay, now similarly if you try along y and z axis, means if you try along y axis, then your x and z 0, and if you matlab, try along z axis, then your x and y equals to 0. Okay, now students, let's try along the curve, along the curve. Now students, along the curve mean converting it into parameterization. Like let us take x is equal to t, y is equal to t, and z is equal to t. Now if you convert all of them into t, now as when your x is equal to 0, then your t is equal to 0, y is equal to 0, then t is equal to 0. So that's why our limit will approach, t approaches to 0. And if we write here and replace, because all are t, then I can write here t times t plus, okay, and is in the denominator we will get t square plus t square plus t square. And if we simplify it further, then we will get limit t approaches to 0, and t square And after that, if you simplify it further, then you will get 3t square over 3t square, and they will be cancelled out with each other, and you will get answer 1. Now as you will write here, as 0 is not equal to, sorry, 1, because here you get the answer 0 and here it is equal to 1. As 0 is not equal to 1, so limit does not exist, and this is your answer. This is so simple to solve in 3D. Means first of all, you have to try along your axis. You can try along x-axis, along y-axis, and along z-axis. But after that, you have to use a path, or you have to use a parameter t. Means definitely, if we talk about the parameterization, then we move along some curve in which our parameter is t. And when I move along that path, then we get a answer 1. And as 0 is not equal to 1, means when we move along the axis, then our answer is 0. But when we move along some curve, then our axis is 1, means both of them are approaching a different limits. So that's why we say that the limit does not exist here. This is all about today's lecture. Thank you so much.